Hey everyone, today's lessons are combined, and so we're doing a work with lesson 114 and 115. Um, it gets a little bit long, but honestly, it just made sense to combine these because they go really hand in hand. So our lesson topic for lesson 114 is using formulas. So just reviewing the formulas that we know regarding perimeter and area and volume, all three really important concepts in fifth grade math. And then also kind of touching on lesson 115, where we're expanding our knowledge about area. And really, this kind of touches into a sixth grade math standard, which is finding area of complex shapes. And we're just using our foundational understanding of finding the area of a shape and how do you use that to find the area of something a little bit more complex that's not like a perfect rectangle, for example? So let's dive in. We have like 5 examples to go through today, all really good stuff. So bear with me. Our learning targets for today we have quite a few because we're combining 2 lessons. First of all, use formulas to solve perimeter, area, and volume problems. Also choose the appropriate formula to solve a problem. So that's huge. I mean, as you advance in your mathematics, earlier on, you've been given formulas and told when to use them. It is a very important skill to be able to look at a problem and to identify independently which formula you need to use. Knowing which one to use when. It's a life skill, it's an important math skill. And I know firsthand too, when we're looking at like standardized assessments on the MCAs, for example, I know that they give you a page. It's like this blank white page and it just has formulas on it. It just says formula page. They don't tell you when to use them, really even differentiate like what the symbols mean. You'll see a formula that just says A equals L times W. And you need to know what that means. So they give them to you, but you still need to know when it's appropriate to use which one. Okay, so we're going to practice that today. Another learning target for today is choose a unit of measure for a given situation. So we're not going to go through one of those examples together right now, but really that's an important skill. Like if I say, I don't know, I want to buy hardwood floor for my kitchen, and I'm looking at how many square feet of hardwood flooring am I going to need to buy. So thinking about, well, I just said feet, but thinking about what's an appropriate unit of measure. Would I say inches? Would I say feet? Would I say yards, miles? Like just kind of knowing, looking at real world situations and determining what unit of measure to use. And then last but not least, calculating the area of figures that can be divided into rectangles. So that's where I said we're going to use that basic knowledge about area and plug that into more complex shapes by just finding smaller rectangles within the complex shape and then adding them up. So here we go. Let's get started with our first example. Oh, just kidding. We're going to just review some formulas really quick. We have some vocabulary right here down on the bottom of the screen. P, perimeter, A, area, V is volume, L is length, W is width, H is height, and B, capital B, is the area of the base. I don't often use this one, but it's there for you. Just reviewing some of these formulas, P equals 2L plus 2W. So that, of course, means the perimeter of a shape is equal to 2 lengths plus 2 widths. So if you think about a rectangle, that makes sense, right? 2 lengths plus 2 widths. So that would give you the perimeter, the outside of a figure. A equals L times W. Area equals length times width. So area equals the length times the width of a quadrilateral or of an object. I'm going to be honest, sometimes I intermix area equals base times height. I'm going to write that in here real quick. And that's not wrong. That's also a fine way to explain it. Area equals base times height. And in math, it's just a matter of vocabulary. Both are right. It's more important that you understand really what we're talking about. If you say base times height or length times width, it doesn't matter as long as you're understanding really what you're doing and why. And then moving on, V, of course, stands for volume, the volume of something. We've just barely touched on that. That really is a standard so important in 5th grade, and it comes at the end of the year. So this is a big concept. We've hardly touched on it. It's something that comes at the end of the year, but volume. See, this gets a little confusing for me. This capital B doesn't mean volume equals base times height. This capital B stands for the area of the base. So I'm going to be honest, this one, the second one here, is the one I've always gone with my whole life. Volume is equal to length times width times height. We're multiplying 3 dimensions, the length, the width, and the height, because we're filling a whole space. Like you can fill the volume of this classroom with air, right? So length times width times height. Some people prefer to think about it this way, so this is a little bit different. Volume is equal to the area of the base times the height of something. And that, of course, makes sense. Like, I wish I would have, ahead of time before making this video, built like a cubic model of a big cubic model. So if you were to find, so to show you, if you were to find the area of the base of something and multiplied it by the height, that would make sense, because it's just multiplying that area however many times the height is. So if that, it makes more sense for you to think about it that way, go for it, because that works as well. Area of the base times the height. And actually, one of our examples that we're going to go through together, I am actually going to use that model just to save us some math, because we're dealing with some bigger numbers. So let's go ahead and give our first example a try. I really do like these example problems because they are very applicable to real world. They're real examples. And some of you know, we just kind of finished remodeling our kitchen. And so some of this stuff is really applicable to me right now. I've just gone through talking about crown molding. So here we go. Just like with every other example in all of my videos, I really highly encourage you to pause it right here so that you can read the problem entirely. Take your time, solve this. When you are confident with your answer, then unpause the video so you can watch as I solve. So as I prepare to solve this, I'm just going to go through and read it really carefully and just make sure I understand what they're asking me. And by doing that, I can determine what formula I'm going to be looking at, depending on what they're asking me to solve for. So I see a diagram here. It looks like a room. I'm given, oh no, this happens sometimes. We lose connection. It will keep recording me, so hopefully it reloads quickly. I'm just going to talk about that picture really quick. Hopefully it reloads. So it was a picture of a room, and they gave us some dimensions. So keeping in mind, in diagrams like that, sometimes in your math, they'll give you, so this was a picture of a room. They gave us a length of the ceiling, but then they might ask a question about the floor. So remembering that in a room, if you have the dimension of the ceiling length, it will be the same for the floor, because our walls don't go like this. They're perfect 90-degree angles, meaning based on those 90-degree angles, if we know the length of a ceiling, we also know the length of the floor. So if the length of the ceiling, for example, is 15, the length of the floor is also 15. Let's see if I can scroll back to where we were. Sorry about that, everyone. Okay, so here we go. The Jacksons have added a dining room to a corner of their house. Mr. Jackson purchased crown molding that will be installed at the intersection of walls and the ceiling. So right here at the top. And my lights just turned off. Okay, so you can't see me as well, but I'm going to keep going. Of his dining room. Crown molding costs $5 per foot to install. What will Mr. Jackson's cost of having crown molding installed? So this is definitely a multi-step problem. Crown molding, just for those of you who have never heard of that before, it's basically like a strip of wood that goes between the wall and the ceiling so that there's not like an ugly line up there. It like makes it look all pretty and nice, and it kind of covers that up. So we're not looking to fill the space. He's not looking to paint his ceiling, cover that whole space. He needs something for the perimeter. That's what we're talking about. I'm looking at this picture here. I can actually see the crown molding right here that he wants to install. We're talking about perimeter. We're talking about that outside. So I need to use my perimeter formula. And I remember that that is P is equal to 2 lengths plus 2 widths. Ooh, I'm off my page. Sorry about that. Can I undo this? Perimeter is equal to 2 length, oh guys, sorry, plus 2 widths. Sorry about that. So we can see, I'm going to call this my length, 15. So 2 times 15, of course, because if that's 15, this is also 15. And then 2 widths. Now, we don't have a width up on top, but we do have a width at the base of 12. If that is 12, this is also 12. And this is also 12. So we have 2 times 15 plus 2 times 12. I'm kind of running out of space really quickly. Oh my goodness. It's hard to write with a stylus pen. 2 times 12. And we end up with, oh my gosh, 30 plus 24. And that becomes 54 feet. I caution you to pay attention. This is not your answer. Go back and read what exactly are they asking for. They're asking what will be Mr. Jackson's cost for having the crown molding installed. So this is important information that we've arrived at 54 feet, but that's really not what they're asking. They're asking how much will it cost. It costs $5 per foot to install. So what do we need to do now? We need to multiply 54 feet times $5 per foot. So here we go. 54 times 5. 4 times 5 is 20. 5 times 5 is 25. 26, 27. He's looking at $270. Yikes, that's supposed to be a dollar sign. In a problem like this, your dollar sign is your label. $270. Let's try another one. We're looking at the same room here now and a different situation. I encourage you to pause the video and give this one a try on your own. As I prepare to solve this, I'm going to just start by reading the problem entirely and really looking at what formula are they asking me to use? What do I need to use in order to solve what they're asking for? So, Mrs. Jackson wants to buy carpet for the dining room floor. How many square feet of carpet are needed to cover the floor? So take a look at this image. You can see here's the carpet right here. We're filling the entire space of something. I know that that's area. We're looking for the area of the floor. And the formula for area, of course, is length times width. Or you could say base times height. That's fine. Length times width. We have our width right here of 12. Oh my goodness. 2s are hard. 2s are really hard with this. Try again. And our length isn't given to us on the base, but we do have it up on the ceiling. So remember, this is 15, so this is 15. And if that's 15, guess what? So is this. And, well, this is kind of broken up. That's a different scenario. But we're going to assume that this is 15 also. So now we have a multiplication problem of 15 times 12. And honestly, how I did this, just trying to save myself some math, I covered up the 2 here. And I said, well, what would 15 times 10 be? That would be 150. And I have 2 left over here. So what would 15 times 2 be? That would be 30. So if I combine those now, I have 180. I didn't know that off the top of my head. I had to break it up a little bit. So now we have 180 square feet. I'm going to write on my video. Can I do that? What if I zoom in? Oh, that made it worse. What if I zoom out? There we go. I'm trying to make my little exponent of 2. 180 square feet. How many square feet of carpet? That's what they're looking for. So that's my answer. Remember, anytime you're doing anything with area, your exponent is 2. That's squared. So, and that's of course because we multiplied 2 dimensions together. We had 2 dimensions, a length and a width. Guess what? Same room again. Okay, so now pause the video, give this one a try, determine what they're asking you to find. I'm going to start by reading the problem entirely and determining what formula I'm going to need to use. So to heat and cool the new room, the Jacksons need to know the volume of the room. How many additional cubic feet of air need to be heated and cooled? So when we're talking about volume, it's like area, but now we're adding a whole new dimension. We're talking about filling the entire space. So this is where we can talk about two different ways to find volume. Volume can either be described as base times width times height. So base times width times height. So you're going to multiply those three dimensions. But also, we talked about how another formula to use for this would be the area of the base times the height. And that's where they used that capital B. Area of the base times height. And lucky for us, we just calculated the area of the base. I'm just going to scroll back up. What was that again? The area of the base, remember, that was our carpet, is 180 square feet. All right, so some of our work is done for us. So we have 180, and we need to multiply that by the height, because now we're not just talking about the floor, we're talking about filling this entire space. Our height is 10. Oh, look at this. We're multiplying by a power of 10. This is so easy. We're reviewing one of those concepts that we did a couple of lessons ago, multiplying by a power of 10. There's no multiplying that you need to do at all. We're literally just going to shift our decimal. So when we're looking at a number and there are no decimals actually present, you assume that the decimal is at the back of the number. So instead of thinking 180, you think 180 point. The decimal's right there. And if we were to shift it, we're going to multiply. So we're going to move it to the right, 1. We end up with 180 with 1 extra 0. Now we're at 1,800 feet. We're dealing with feet. Oh no, I ran out of room again. I need to zoom out further. And anytime we're dealing with volume, of course, our exponent is cubed. It's an exponent of 3. You could read this as 1,800 cubic feet. In your homework today, there wasn't a way for me to use a small number exponent when I was typing out your homework in Google Forms. So you'll notice in your homework, the word cubed is typed out. It means the same thing. You can do that just as you advance in your math, or if you choose to submit your homework manually on paper, just use your exponent of 3. And that's, of course, because we're multiplying 3 different dimensions together, base and width and height. Let's keep moving. This example right here, go ahead and pause the video, try both of them. So, the Jackson son, Demont, has a trunk in his room for storing toys. And we have the 3 dimensions, notice here. That's all we need. To be honest, anytime I see a math diagram or an image like this and I'm given 3 dimensions, my brain automatically thinks about volume. They probably want me to think about volume. They gave me 3 dimensions. Don't always assume that, but it's a good thing that your brain starts thinking in those terms. So let's read A and see exactly what they want us to solve here. Mrs. Jackson plans to put a liner on the floor of the trunk. Okay. Choose a formula and use it to decide how much area the liner will cover. Okay, so a liner is just going to be like a thin, flat thing under the trunk. We're talking about area then. We're talking about this length times the width. Okay, so length times the width, that would be, okay, so first of all, I'll write that out. Area is, length times width. In this case, it's 36 times 30. I'm going to get rid of that 0 for now and multiply and add it at the end. 6 times 3 is 18. 3 times 3 is 9, plus 1 more is 10. Add in my 0 back. We have, it's really hard to write legibly with this. 1,080 inches squared, or square inches. Try again. Nope. You guys, it's not letting me make a 2. Okay. 1,080 square inches. Let's read B. Mrs. Jackson also plans to paste a border around the entire trunk. Choose a formula and use it to determine the minimum length of the border she needs to buy. So when we're talking about a border, we're not talking about filling the trunk with anything. He's going to fill that with toys. We're talking about perimeter, right? We're going around the side of the trunk. So let's see, I'm kind of running out of room, but of course we talked about perimeter is equal to 2 length plus 2 width. And we have length and width. They've given us height here, and we don't even need it. We didn't even need it. So you shouldn't assume volume. We didn't even need that. We have 36 times 2 plus 30 times 2. Oh, I'm running out of room. 36 times 2. You know what? I'm actually going to go back and think about that mentally just to save us some room. 36 times 2. 36 times 2. Well, 30 times 2 would be 60. 6 times 2 is 12. 60 plus 12 is 72. Plus, our width here is 30. So 30 times 2 is 60. And we have 132, and these are inches. 132 inches. And remember, when you're doing perimeter, there's nothing squared. We're not filling the space. It's just inches. 132 inches of that border she needs to buy. Okay, so this is our last example of the day, and it's just that thing I was mentioning in the beginning about area. So remembering what we know about area being length times width, how can we look at this complex shape and break it up into smaller rectangles, add those together, and find the total area of, let's say, a room or something, just any type of complex shape that isn't a perfect quadrilateral, for example. So go ahead and pause this video, give it a try. We've never done one of these before, but challenge yourself anyway. Go ahead and pause it, give it a try, and when you think when you're confident in your answer, unpause it so you can do some self-check with my work. Okay, so as I look at this, 2 rectangles are joined to form a hexagon. What is the area of this hexagon? So taking a look at this, what I need to do, I'm actually going to zoom in. Maybe that's a little far. What's the area of this hexagon? I'm going to break it up into 2 smaller rectangles. So visually, my mind wants to break it up here. I'm trying to do a dotted line, and it's not working all that well. So I'm just going to draw a line. Okay, so if I break it up like that, I'm just going to take length times width of the smaller rectangles and add them together. So 4 times 3 is 12. And 5 times 7 is 35. So if I were to add those 2 together, I get 47, and this is area, so I need to make sure I'm mindful of that when I do my labeling. 47 square feet. Easy as that. All right, everyone, that's our last example for today. Thanks for sticking with me through that long lesson and losing our document for a minute and losing the lights in the classroom. I appreciate it. Have a great day. If you need any reteaching of any of these concepts, just replay the video. I will, of course, attach these notes in Google Classroom, as well as your homework will be found there. So yes, thanks. Have a great day. See you later.